Welcome back, students, to another class in solving problems in kinematics. Today we'll be solving a few problems based upon the concepts of differentiation and integration. We have discussed a full-length chapter on differentiation and integration while discussing the topic of mathematical tools in physics, and there I had told you that these two topics will be extremely important in several derivations, proofs, and solving several numerical problems in the syllabus for class 11 physics. Even though some of these topics will be covered up in greater detail in mathematics, but still the concept of calculus is very important when it comes to understanding the concepts of physics. Today we will be applying the learned concepts, that is the elementary results, the standard values that we had discussed in the topics of differentiation and integration. Today we will be implementing these results and solving a couple of problems in kinematics. Before we actually discuss the problems, let me remind you a couple of important expressions that we will be making use of. Let's begin with y equal to x to the power n. I had told you that this is a very important result when it comes to derivation. So when y is equal to x to the power n, the derivative, that is dy by dx, that is equal to n x n minus 1. Similarly, if you are having integral x to the power n dx, that will be equal to x to the power n plus 1 by n plus 1. Here the condition is that n is not equal to minus 1. If you are having integral dx, then we can write down integral dx as x to the power 0 dx, because anything raised to the power 0 is 1. So that will give us x to the power 0 plus 1 by 0 plus 1, and that will be equal to x. So these are few results that we'll be making use of while solving these numerical problems. Let's proceed to the first question. The displacement of a particle is proportional to the cube of the time elapsed. How does the acceleration of the body depend on time elapsed? Now, in this question it is given that the displacement of the particle is proportional to the cube of time elapsed. So if x is the displacement at time t of an object in motion, let x be the displacement at time t of an object in motion. So it is given that x is proportional to t cube. So now we can write down x to be equal to a constant times t cube. K is the constant of proportionality. Therefore velocity is equal to dx by dt. So we have to differentiate the expression for x, that is k t cube. So that will give us 3 kt square, isn't it? We will get velocity equal to 3 kt square. Now let's find out acceleration. If acceleration is given by a is equal to dv by dt. Just now we have obtained an expression for v, and that came out 3 kt square. So that will be equal to how much? We can keep out 3, it is constant, k is constant, and t square, the differential will become 2t. So that will give us 6 kt. Therefore acceleration is directly proportional to time. As 6k is constant, so we can write down acceleration is directly proportional to time. Next question. The displacement x of a particle along a straight line at time t is given by x equal to alpha minus beta t plus gamma t square. X is equal to alpha minus beta t plus gamma t square. Find the acceleration of the particle. So we can write down the expression for x. X is equal to alpha minus beta t plus gamma t square. So velocity v will be equal to dx by dt. That will be equal to how much? Alpha is a constant, so differentiation will be 0 minus beta t. Differentiation will be beta. Differential of t is 1, so beta into 1 plus gamma into differential of t square is 2t. So that will give you v equal to minus beta plus 2 gamma t. So now acceleration, that is equal to dv by dt, that will be equal to d by dt of minus beta plus 2 gamma t. So that will give you 2 gamma. So acceleration is equal to 2 gamma. The next question. An electron starting from rest has a velocity that increases linearly with time as v is equal to kt, where k is 2 meter per second square. What will be the distance covered in first 3 seconds of its motion? An electron starting from rest, so the initial velocity of the object is 0 and it increases linearly with time, so as v is equal to kt, k is 2 meter per second square. So what will be the distance covered in first 3 seconds of its motion? So now we can write down v equal to, sorry, just let me correct it, v is equal to dx by dt, and velocity is given as k into t. So now we can write down dx equal to kt dt. Now we can integrate both sides. So integrating both sides, you have integral dx equal to, now check out, in this expression k is constant, so we can keep k out of the integral sign, so k integral t dt. So on integrating you get x equal to k t square by 2 or half kt square. So for t equal to 3 seconds, we have x equal to half the value of k, if you remember, it was given 2, so 2, and t square, that is 3 square by 2. So you can cancel out 2 and 2. Now just a minute. Okay, so now we can write down 2 and 2 gets cancelled, so that is left out with 9 meter. We've already put 2 first, so half into 2 into 3 square, so that will give us 9 meter. So the displacement is 9 meter. Next question. Displacement is given by x equal to 1 plus 2t plus 3t square. The expression for displacement is given as x equal to 1 plus 2t plus 3t square. Find the value of instantaneous acceleration. Find the value of instantaneous acceleration. Now, A is equal to dv by dt, isn't it? D by dt, and in place of v I can write down dx by dt. So this turns out to be a double differential of x with respect to time. So you should remember acceleration is equal to d2x by dt square. It is given x is equal to 1 plus 2t plus 3t square. So very easily, first of all, let us find out v, that is equal to dx by dt. So that will be equal to d by dt of 1 plus 2t plus 3t square. It will yield 2 plus 6t. Now acceleration is equal to dv by dt, so that will be equal to d by dt, and what was v? V is 2 plus 6t, so that will give you 2 is a constant, so that will yield 0 plus 6, and differential of t is 1, that will be 6. So 6 units, that is the acceleration. A particle moves along x-axis in such a way that its coordinate x varies with time t according to the expression x equal to 2 minus 5t plus 6t square. X is equal to 2 minus 5t plus 6t square. Find the initial velocity of the particle. Find the initial velocity of the particle. So now v is equal to dx by dt. So we can differentiate d by dt, and x is 2 minus 5t plus 6t square. That will give you 0 minus 5 plus 12t. Now, for initial velocity t is equal to 0. Therefore, v will be equal to 0 minus 5 plus 12 into 0. Isn't it? So that will give you minus 5 meter per second. So this is the value for initial velocity, that is minus 5 meter per second. The relation between time t and distance x is t equal to alpha x square plus beta x, where alpha and beta are constants. Show that retardation is 2 alpha v cube, where v is the instantaneous velocity. We are having the expression for time, and it is related with the distance traveled x as alpha x square plus beta x, where alpha and beta are constants. We have to prove that the retardation is 2 alpha v cube, where v is the instantaneous velocity. Simple. So we have to differentiate the value of x in order to find out what is velocity, and then we can find out what is acceleration. So let us begin with the given expression. T is equal to alpha x square plus beta x. Differentiating it with respect to time. This means we are finding the differential of t. So dt by dt, that will be equal to alpha, or rather I can write down d by dt of alpha x square plus beta x. Okay, so now this will become 1 equal to alpha. What is the differentiation of x square? That will become 2x into dx by dt plus beta dx by dt. So if you take out dx by dt as common, you will get 1 equal to dx by dt. In brackets you will have 2 alpha x plus beta, or you can write down dx by dt. Now dx by dt is what? That is equal to v. That will be equal to 1 divided by 2 alpha x plus beta. So now we are having the expression for velocity. We know that acceleration is equal to dv by dt. So this means we have to differentiate the expression for velocity, and velocity was coming 1 by 2 alpha x plus beta. So this may be written as when you differentiate it, you will get 2 alpha x plus beta. Keep it, differentiate 1, that will become 0 minus, keep 1, differentiate the term, that will give you 2 alpha into dx by dt divided by 2 alpha x plus beta whole square. You will get this expression. Now before we proceed further, let me remind you that we have used the form when y is equal to u by v. If y is equal to u by v, so we keep the second function v, differentiate the first, minus differentiate the second function, keep the first, divided by square of the second function. So we have used the same rule over here. In this case u is 1 and v is 2 alpha x plus beta. So we have kept the second function first, 2 alpha x plus beta, differentiated the first one, that is 1, differential of 1 is 0, minus, keep the first function 1, differentiate the second, so 2 alpha, differentiation of x is dx by dt, plus beta, differentiation of beta is 0, divided by square of v, so 2 alpha x plus beta whole square. So we have used this expression. Now let us solve it out. The first term, since it is multiplied with 0, that will become 0. So we are left with the second term, dx by dt is v. So we can write down a equal to minus 2 alpha, see, minus 2 alpha, and in place of dx by dt, what shall we write? V. And divided by 2 alpha x plus beta whole square. Isn't it? So now this will become equal to minus 2 alpha v cube. Why? Since v is equal to 1 by 2 alpha x plus beta, isn't it? Therefore v square will be equal to 1 by 2 alpha x plus beta whole square. So we can put this v square here. See, it's the same thing now. So in place of 1 by 2 alpha x plus beta whole square, we can substitute v square. So minus 2 alpha v into v square, that gives us minus 2 alpha v cube. So this is the expression for acceleration that we were supposed to obtain. Now let's switch over to this expression, this question. The acceleration of a particle is given by a equal to 3t square plus 2t plus 2, where t is the time. If the particle starts out with a velocity v equal to 2 meter per second at time equal to 0, then find the velocity at the end of 2 seconds. We are having the expression for acceleration. The acceleration is given by 3t square plus 2t plus 2. Time is given by t. Particle starts out with the initial velocity 2 meter per second at t equal to 0. Obviously at t equal to 0 you are having the initial velocity. Then find the velocity at the end of 2 seconds. So how shall we solve it? So we are given with the expression for acceleration. So obviously we will begin with a equal to dv by dt, and that is given as 3t square plus 2t plus 2. So now we can write down dv equal to 3t square plus 2t plus 2 into dt. Simple. So now we have to integrate. So integrating both sides within the conditions of motion, we have integral dv equal to integral 3t square plus 2t plus 2 into dt. Now we will substitute the limits. Okay, we will substitute the limits. At time equal to 0 the velocity is 2, at time equal to 2 the velocity is v. So over this limit we can integrate this expression. Let us carry out the integration. So on the right hand side of the expression you are having 3t square plus 2t plus 2 whole dt, integral on the limits 0 to 2. On the left hand side you are having integral dv over the limits 2 to v. So obviously we will get integral of dv as v. Let us put the limits, that is from 2 to v. On the right hand side you get 3 into t square, that becomes 3t cube by 3 plus 2, it becomes t square by 2, and this becomes 2t, and the limits are 0 and 2. So 3 and 3 gets cancelled, 2 and 2 gets cancelled, so you are left with v minus 2, and on this side you are having 2 cube plus 2 square plus 2 into 2, and obviously when you put 0 in place of t the result will turn out to be 0. So this becomes v minus 2 equal to 8 plus 4 plus 4. So that gives you v minus 2 equal to 8. Sorry, I can substitute the result. 8 plus 4 is 12. 12 plus 4 is 16. So that gives you 16. So v is equal to 16 plus 2. So that gives you v equal to, let me just clear it up, v is equal to 16 plus 2, 18 meter per second. So in this manner we can find out the value of velocity. So hopefully after seeing the solution of all these questions that we have solved using the concepts of integration and differentiation, it must be very much clear to you all that using the same elementary formula, the same standard integral, either it was integral x to the power n dx equal to x to the power n plus 1 by n plus 1, or we have used the differential where y is equal to x to the power n and dy by dx becomes nx n minus 1. So using these standard differentials and integrals only we have been solving all these questions, isn't it? So straight away you can consult any reference book and solve a more number of questions, so that these sort of questions becomes very much clear to you. And as and when these type of questions are asked in the examination, it is just not a problem, and you can easily figure out whether you have to differentiate or integrate. Okay, so if the expression for position is given in the question, and then you are asked to find out velocity, you have to differentiate. If you have to find out acceleration, you have to differentiate. If the expression for acceleration is given in the question, you have to find out velocity. Using the expression for acceleration, you have to integrate, then you will get velocity. Integrating the expression for velocity, you will get position. So you should be able to figure out. That's the thing that you need to work upon, and this will become easy with the more number of problems that you practice. For that, you can consult any reference book of your choice and practice more number of questions. Thank you.